All right, today we're going to talk about converting between logarithms and exponential functions. We're going to go both ways. We'll convert the exponentials first to logs, and then we'll go to the exponentials. But a couple of things I want to talk about before we go too far. A couple of reminders. Remember our common log that we will see, and remember when we just have a log of a value, that's called a common log. It's an understood base 10. And then the other thing, we won't see this one today, but a natural log is basically saying log of E, log of Euler's number. So those two things, we need to keep those in mind as we move through. We will be seeing this one today. This one we won't see today, but we do need to keep those in mind when we do these conversions. First thing we're going to want to do is to copy down these two formulas for yourselves. You'll need these. We'll use these throughout the day. And this is the conversion method from turning both logarithms to exponential functions and then back from exponentials into logarithmic functions. One thing I want to highlight to you, and you should be writing these down. One thing I want to highlight to you, whatever the log base is, will be the base of the exponent. So that's where we always want to start, is with the base. Again, whether it's the base of the log or it's the base of the exponent, start with the base and work this way. And now what we want to do is start at our base, either one, and we're going to go down and make a counterclockwise swirl and get back to this spot right here. So we always start at the base, again, go down and around. So we go base. The next thing we see is the C value, and then we actually cross the equal sign and we get the A. So that's how we convert a log base into a exponential function. And again, all this is meant to do, log bases and exponentials are inverse functions, so they basically undo one another. But we're first going to find the nature of these two. Now, the conversion of exponential to log base is the same process. The first thing we do is identify our base. We start at the base, and again, down and around, and it's going to be a counterclockwise swirl, and it's going to end right there. So the base of the exponential is the log base as well. And I'm missing something in my formula, so you can add this on too. So log base of B of A, and then what we're missing is the equals C. Equals C. So go ahead and add that to your notes while we're thinking of it. So this is really the premise of everything we're going to do. Keep this somewhere handy so you can go back and look at it, but it's pretty easy to get accustomed to because it's the same movement all the time. So let's just take a look at this example here. This example is not on your Delta Math. You're welcome, as soon as you figure out how we're doing this, you're welcome to work on your Delta Math. But take a look at a few of these, and there's one that I definitely want you to see. So when I get your attention, make sure that you are watching that one. So the log base will be the base of the exponent. And as we said, we're going to do this counterclockwise right there. So the next number I run into is 5 to the second power equals 25. Now, what a logarithm is set up to do is to explain the powers, and it's basically saying what value base of 5 results in the amount of 25, and that would mean the exponent is 2. That's what logarithms say. A little harder to read than exponentials. We're very familiar with exponentials. We're not as familiar with logarithms. I'm going to throw some weird looking ones at you today, but don't be confused. It's always the same process. First thing we're going to do is identify the base. So since this logarithm has a base of 16, the resulting exponent is going to have a base of 16. And here's why I even said the down and around here, because a lot of times people want to run into this 1/2, but we want to go down and around this thing. So we will go down and around and then finish at the 1/2. So the 16 to a negative 1/4 power equals 1/2. Here's the other thing about this particular topic. You shouldn't miss any of these, because if you were to put this in your calculator and hit enter, the result is going to be 1/2. Same with the previous ones we looked at. These are not equations. These are literally just statements, but we're just practicing the conversion for when we do get some variables. And we'll throw some variables in today, but we are not going to solve today. We're just trying to get accustomed to the nature of a logarithm. This is the easiest one, but the most commonly missed. Again, it is still the same process. We identify the base, which is 12. We're going to go down and around, so just like that. So this would be 12 to the 0 power equals 1. Now that's an important piece of what we're doing. Remember, anything to a 0 power is 1. Another thing you need to consider is anything to the 1 power stays the same. So if we're trying to get a common base and we have a number of 1, you basically can make any number. If I wanted to make a base of 2 equal to 1, it's just 2 to the 0 power equals 1. You'll actually see that on one of your homework, so think about that as you move through when you're trying to get a common base. And again, all I can do is try to make these look a little more complicated, but at the end of the day, it's always the same process. We start at the base, which will be the base of the exponent. We do our counterclockwise swirl. So this would be 1/5 to the 2nd power equals 1/25. So that's how we make that conversion. I think we're kind of getting accustomed to the process here. We're going to move to exponentials, but we're also going to pick up the pace a little bit. For those of you that think you got this figured out, you probably do. But do take a look at an exponential before we go too far. So here's an example with our exponential. But again, everything starts with the base. So this has a base of 144. So when we redo this as a logarithm, it's going to be log base 144. And the same process, it's down and around that counterclockwise. So it's going to be log base 144 on 1/12 equals negative 1/2. Now we already know how to use our calculator to plug in a log base, so since we know that, we can also check our answers. If we were to hit our alpha F2 option 5, that's your log base option, and we were to put this information in that I highlighted and hit enter, the result's going to be negative 1. Because this is not an equation, this is a statement. So you can verify this statement with your calculator. Here we are again. We've got an exponential that we want to convert into a logarithm. So this exponential has a base of 1/19. That's no big deal. We just go to our log base, and the log base is 1/19. We're going to go down and around. So before we cross the equal sign, we need to put this 1/361 equals the exponent 2. And again, this is verifiable with your calculator. You can use the alpha F1 function, the fraction function, to set these up. That's what I always do. I try to make them look exactly like the equation. But verify your answer. I want to talk about something as well. So while I'm looking at this, I hope everybody understands. Hopefully you can see my writing kind of looks a little bit off here, but the log base and the 1 over 361 are on the same level here. And the 1/19th is subscript. I don't want anybody to think that that's a power. That is all on the same level. Nothing special about this one. It involves a 0. A lot of people miss these, but it's actually the easiest one we do because anytime you have a 0, there's a 1 involved. So this is log base 3, 1. Now when this value right here is equal to 1, the result on the other side has to be 0. All right, those of you that have been working ahead, this is the point where I was talking about where I want your attention. So if you are working ahead, let's just put on pause what you're doing and make sure you take a look at this one. This one will catch you off guard. It's the same process. This one looks very intimidating, but it's really not. What we're asked to do is write a log equation as an exponential function. You do not need to solve for x. So I'm going to move this thing up here now that we've got these directions. So here's where this can be confusing. We're missing a log base. But in actuality, we are not missing a log base. Think about what that means. When we do not have a log base where it's supposed to be, what are we looking at? Hopefully you're recognizing that this is that common log. Remember, it's common log because of science. The scientific notation always deals with 10, so we just use that common log 10. So what we do when we want to make this conversion is you can literally come in and write the number 10, or you can just recognize that this is the value 10. But it's still the same exact process. I have a base of 10, which means when I make the conversion, my exponential will have a base of 10. Same process, we are going to go down from the 10 and way around because there's a lot of stuff going on in there. So the next thing I come to is my exponent. You can use parentheses here. You probably need to use parentheses when you put it into delta math, but this is going to be 2x plus 4. Then we come across the equal sign, and then we finish off on the other side, which is x squared minus 5x plus 14. So that question looked very intimidating. But you see, it's all the same process. It's all the same process here. Don't worry about what this looks like. Just follow the process. We start at the base, and we go down and around in a counterclockwise movement, and we end up as this on the other side of the equal sign. Eventually we'll solve. We won't be solving many like this, but we will eventually solve these values. But first thing we need to do is recognize how to make the conversion. All right, you guys have a delta math. Be careful on the first 12 questions. You do not get multiple attempts. So take that time and make sure that you do check your answers with your calculator because they're all conversions. So you miss the first attempt, you better put the values in your calculator. Make sure that those actually are the correct ones. Good luck.